The commutative property of multiplication states that the factors in a multiplication problem can trade places and trade meanings, but the total will stay the same. For example, 5 times 2 equals 10, and 2 times 5 equals 10. Let's take a deeper look into what exactly that means and why this property is helpful. Here is an array that shows 5 rows of 2, or 5 groups of 2. We can see from skip counting by 2's that the total is 10. 2, 4, 6, 8, 10. So we can represent this problem as 5 times 2 equals 10, because the first factor should represent the size of groups, or rows. The second factor should represent the size of the group. So 5 times 2 is 5 rows of 2, just as you see in the array. Now, if we rotate this array 90 degrees, we can see that the total did not change. We did not add any dots, and we didn't remove any dots. However, the number of rows became the number of columns, and the number of columns became the number of rows. So now we have 2 rows of 5, which can be represented by 2 times 5 equals 10. Again, the total did not change, it stayed the same. So the 5 and the 2 traded places and traded meanings. 5 was the first factor that represented the number of rows, and it switched places to be the second factor, which then represented the size of each row. 2 was the second factor that represented the size of each row. It traded places and became the first factor, cat here, which represented the number of rows. So the factors then commuted, which is a word that means to travel from one place to another, but the total remained the same. Now this property is helpful because it can help us solve some multiplication problems more efficiently. For example, if you are trying to solve 10 times 3, which means 10 groups of 3 or 10 threes, you could skip count by 3's 10 times to find out the total. 3, 6, 9, 12, 15, 18, 21, 24, 27, 30. But it would be more efficient to trade the factors and switch them to be 3 times 10 or 3 tens, 3 groups of 10, because our scholars can skip count by 10s 3 times much faster than they can skip count by 3's 10 times. It's just more efficient. So they can go 10, 20, 30 to get the answer more efficiently or more quickly. Let's look at another example. If you are trying to solve a more difficult problem, maybe with a larger factor, such as 25 times 2, you could skip count by 2's, since this is 25 2's. You could skip count by 2's 25 times, but that would take forever. Our kids don't have that many fingers, so they end up getting confused and getting the wrong answer. But if you use the commutative property, you know you can switch the factors, and instead of 25 2's, it can be 2 25's, or 2 groups of 25, which is easy for our scholars to add in their heads or add mentally. 25 plus 25 is 50. So they would arrive at the answer much quicker if they just switched the factors, knowing that 25 times 2 would have the same product as 2 times 25. Let's look at one last example. If you're trying to solve 5 times 7, you could represent this as 5 groups of 7, or 5 sevens, right here. Or you could represent it as 7 5's, which would be easier for our scholars to figure out because they know how to skip count by 5's very quickly and very efficiently, but we haven't quite learned how to skip count by 7's yet. So they would have to add 7 plus 7 is 14, plus 7 more, plus 7 more, plus 7 more, which would take them longer. So the commutative property is just a law of multiplication that says that factors in a multiplication problem can trade places and trade meanings, but the total will remain the same.